So here we have a little demonstration of a ratio of an exponential function, f of x equals a to the x, or b to the x. It doesn't really matter what the variable on the base is, where the base is 1.80. We notice that the slope of the tangent, which is the gradient of the tangent to this function, divided by the function itself, in this case has a ratio of 0.59. So if I were to take point A and drag it along the curve, notice that this ratio does not change. And also notice that point D, which is the value of the derivative, that value of the derivative, i.e. the slope of the tangent, is sort of mimicking the actual function itself. Okay, so the important thing is to notice that that ratio of the slope of the tangent, or the gradient of the tangent, over the function itself is a constant. Now I'm going to change this base to 2.0, and I'm going to do the same thing now. I'm going to drag A. Notice now that the ratio is a greater number, but it's still constant as I drag this point A along the curve, and point D, the derivative, is mirroring or very, very close to the function itself. I'm going to go in here and change this again. I'll change it to a larger number just for brevity's sake. And notice that the ratio is now 0.92. And notice that the derivative function is getting very, very close to being directly on the actual function itself. I'll change this again to get a little bit closer still. And here the ratio is 0.99, which is much greater. Notice that the derivative is actually very, very close to being right on the actual function itself. Thus would explain this ratio of 0.99. Now let me see if I can change this to something maybe a little bit more accurate. Maybe to 2.71, maybe 2.718, as I'm going to cheat a little bit. And the d value, the derivative, is riding right along the length of that curve. And notice, of course, the ratio of the gradient of the tangent with the function itself is actually 1. Therefore, the gradient and the function itself have to be equal all the way along, the curve. Okay, and that's at this number of 2.72, which is just an approximation, but for our purposes it will do its job.